So a large, complex model, such as this HEV system, presents a number of challenges to understanding behavior. The plant combines rotational and rigid body dynamics with electrical effects from the motor and generator and dynamics expressed in block diagrams. The controller has similar complexity, spanning a deeply nested block diagram that includes an elaborate state diagram, which incorporates logic and subcharts that eventually include embedded block diagrams with numerical computations for those states. The simulation dynamics span a range of operating conditions captured in a vast set of log data. And within this data, issues might appear at specific times in the simulation, such as this plot of engine speed that becomes negative, indicating likely engine damage and unknown results for the remainder of the simulation. In a typical workflow, Model Slicer helps you understand and isolate this type of troubling behavior. It takes models and simulation scenarios as input, and when given an area of interest expressed as a portion of the design, a block or a signal of interest, and a time interval, it highlights the relevant parts of your model. And as of 2016B, this includes the active parts of your Stateflow diagrams. And you can interactively adjust your area of interest to better understand the causes of undesired behavior. So let me show you how this works in practice. I have the model loaded, and I've started Model Slicer, and I'm interested in understanding what affects the engine control mode. So I'll make that a starting point of slicing. Now, highlighting will indicate the blocks that are significant as I navigate through the block diagram hierarchy. And I can look for issues, but everything looks okay in the block diagram, so I want to come back out and look at the state diagram. And now I can see that everything is highlighted. So what I want to do is focus on the problem area. And I'm going to zoom in and look at that area of negative speed that doesn't make sense. And I'm going to look at a small window. And now I can see the states that are active, and I see a problem. I have two parallel states that should be synchronized, but somehow I have an invalid state combination. So what I might do is go back to that time trace and try to understand what happened just before to cause this. So I'll widen that, and now I can see more details to the failure. The engine was starting, yet somehow the generator start was not reachable, and this was due to a missing transition, which I can now add. So I've shown you how you can start with a complex design model and highlight areas of interest. Sometimes you need to capture that simplification in a separate model, and this is done by creating a slice model. Slice models eliminate unnecessary blocks and simplify model content. The resulting model is easier to understand and simpler to analyze and debug. The workflow is completed with navigational affordances that help you incorporate changes back into your original model. So in summary, Model Slicer provides a simple system to explore and isolate troubling behavior from your large design models to help you improve quality.